Hello and welcome back to the final IB Math speedrun of today with me, Vince. So we're going to be covering double angle identities, and that will wrap up our trigonometric identities section. So let's jump right in. So now we know that, of course, that is my text, yes. Now we know that sine A plus B is equal to sine A cosine B plus sine B cosine A. Well, what if we're putting two of an angle? Say, what will sine 2A be? Well, we can simply expand this to sine A cosine A plus sine A cosine A using the above formula, which is equal to 2 sine A cosine A. So that's the double angle for sine. The double angle for cosine, you can repeat the similar process, but it's equal to cosine squared A minus sine squared A. And for tan 2A, is equal to 2 tan A over 1 minus tan squared A. Yeah, these are double angles. They're also half angle formulas, and we can derive them as well, but the double angles are generally easier to remember. Now, there is one thing, however, that deals with this cosine A, and it's the fact that we can apply another identity, namely sine squared A plus cosine squared A is equal to 1 to make some changes to this. So if you notice, this can also be equal to 2 cosine squared A minus 1, and it's also equal to 1 minus 2 sine squared A. So those are the two variations on the cosine formula. And yeah, so with all of these identities, especially using these double angle, compound angle, and other trigonometric identities, one of the most common things to appear in a test is to prove different trigonometric identities using these base identities. Yeah, so I think that's what we're going to be doing right now. So let's jump into proving some identities. So guess I'll do the odd ones, why not? So prove the following identities. I'll just write them out. The first one is tangent A plus cotangent A is equal to 2 cosec 2A. So how do we prove this? Let's manipulate this side first. Actually, no. We can manipulate this side first. So we have sine A over cosine A plus cosine A over sine A. So multiplying both by sine and cosine, we get sine squared A plus cosine squared A over sine A cosine A. I believe that's what we get. Yeah. And so, of course, sine squared A plus cosine squared A equals 1. So we have 1 over sine A cosine A. And so this is actually equal to, I mean, if you notice, 2 sine A cosine A is equal to sine 2A. So we can also rewrite this as 2, or actually 1 over 1/2 sine 2A. And 1/2 sine 2A, well, we can move this up here. So this is equal to 2. So we have 2 over sine 2A, which is 2 cosec 2A. So that's successfully proved it. Next, we have cosine 3x minus sine 3x over 1 minus 2 sine 2x is equal to cosine x plus sine x. So at the top here, we can say this is going to be cosine x cosine 2x minus sine x sine 2x minus, and then we have sine 3x, so this is equal to sine x cosine 2x minus sine 2x cosine x all over 1 minus 2 sine 2x. Yeah. So all over 1 minus 2 sine 2x. So if we factor out the top, what we get is we get sine x, so we have, let's do cosine x first, so cosine x times cosine 2x minus sine 2x minus sine x times cosine 2x plus sine 2x. Okay. And it's all over 1 minus 2 sine 2x. Okay. So where can we go from here? 1 minus 2 sine 2x is 1 minus 4 sine x cosine x. But that doesn't look like it's going to help. I guess we could just expand everything. I'm just looking if there's an easier solution. No, there doesn't appear to be. Okay, let's expand everything. So we're going to get up here cosine x cosine 2x will be equal to cosine x times cosine squared x minus cosine x times sine squared x minus 2 sine x squared cosine x minus cosine squared x sine x plus sine cubed x. Yeah, minus sine 2x cosine x. So this is minus cosine squared x sine x minus 2 cosine x squared sine x. What is this? So we can factor out sine x from everything. No, we can't. Oh, cosine x squared cosine x is equal to cosine x cubed. So this is cosine x cubed minus cosine x sine squared x minus 2 sine x cosine squared x. Minus 4 of that actually. Okay, so we can actually factor the bottom into something, because this is equal to sine squared x plus minus 2 sine 2x plus cosine squared x. So this is equal to sine x minus cosine x squared. So what we have here is, well, we can try and divide it actually to, oh actually wait, that's different. I didn't realize that. So this is actually equal to, oh okay, sine x cubed minus three sine squared x cosine x minus 3 sine 3 sine x cosine squared x plus 3 cosine x cubed. And so this should factor out simply into sine x plus cosine x times sine x minus cosine x squared. And since it's being divided by that, we can cross that out, and so we're left simply with sine x plus cosine x. Is that what we needed to prove it equaled? Yeah, cosine x plus sine x. So that is the answer. Okay, next. we need to do this. So if tan A is equal to 3/4, find sine 2A and sec the secant of 2A. Oh wait, that's the wrong one. We need to do use the fact that 4A is equal to 2 times 2A to prove sine 4A over sine A is equal to 8 cosine cubed A minus 4 cosine A. Okay. So sine 4A over sine A is equal to sine 2A times 2. So this will be equal to, what is this? 2 sine 2A cosine 2A all over sine A. And we need to prove this equals 8 cosine cubed A minus 4 cosine A. So what this is 2 sine A cosine A, and so we can immediately cancel out sine A, times cosine squared A minus sine squared A. So, and then we can expand this even more by converting this into 2 times 2 cosine squared A minus 1. Oh, sorry, this should be times 2 again. So this should be 2 times 4. So it's 4 times 2 cosine squared A minus 1. So this is equal to 8 cosine cubed A minus 4 cosine A. So that was a pretty good proof. Okay, next one, we need to prove that express sine 3x and cosine 3x in terms of sine x and cosine x, respectively. So, okay, I mean, we've already pretty much tackled this one. So sine 3x is equal to sine 3x is equal to sine x cosine 2x plus cosine x sine 2x. So that's equal to, we have this is cosine squared x minus sine squared x, so it's cosine squared x, but we can rewrite that as 1 minus 2 sine squared x, so this would be sine x minus sine x minus 2 sine x cubed plus cosine x times sine 2x is equal to 2 sine x cosine squared x, which is equal to 2 sine x times 1 minus sine squared x. So this is equal to plus 2 sine x minus 2 sine x cubed. Yeah, no, this looks right. So we have negative 4 sine cubed x plus 3 sine x. So that's sine x cubed. Sorry, sine 3x is equal to that. How about cosine 3x? So this is equal to cosine 2x cosine x minus sine 2x sine x. So this is equal to cosine cubed. Actually, this would be 2 cosine cubed x minus cosine x minus sine 2x minus sine x. So this would be minus 2 sine squared x cosine x. So this would be minus 2. So plus 2 cosine cubed x minus 2 cosine x. So this would be equal to 4 cosine cubed x minus 3 cosine x. So we can note a little pattern there. Yeah. Okay, on to the next one. In the next one, we need to express tan 4a in terms of tan A. This is going to be ugly. So we have tan 4A is equal to 2 tan 2A over 1 minus tan 2A squared. So that's the simple-ish part. Now we need to substitute what tan 2A is. So we have 2 times 2 tan 2A. So we have 4 tan 2A over 1 minus tan A squared. Sorry, we have 4 tan A over 1 minus tan A squared. All over 1 minus, and then it is 2 tan A over 1 minus tan squared A squared. So if we multiply everything by tan squared A squared, we get 4 tan A times 1 minus tan squared A all over 1 minus tan squared A squared minus 2 tan A squared. So this would be minus 4 tan squared A. It looks like we might be able to factorize this actually. So how much do we have to simplify this exactly? Oh, we don't have to simplify it any further. So this is fine by the book. So that's done. And so we're on to the final question. And the final question asks, find the values of x between 0 and 2 pi such that cotangent 2x is equal to 2 plus cotangent x. Okay, this is a nice little problem to finish it off. So cotangent 2x is, of course, equal to, pull this out of the memory bank. This would be, we proved this earlier. Oh, it's, wait, sorry, I'm having a blank. Here, it is cotangent 2x is equal to 2 cotangent x minus 1, sorry, cotangent x squared minus 1 over 2 cotangent x. So we need to find the values for what this is equal to 2 plus cotangent x. So if we multiply both sides by 2 cotangent x, we have cotangent x squared minus 1 is equal to 4 cotangent x plus 2 cotangent squared x. So we have cotangent x squared x plus 4 cotangent x plus 1 is equal to 0. And so this would factor into, let's just put it into quadratic formula. So we have cotangent x is equal to negative b plus or minus the square root of b squared minus 4ac minus 4 over 2a. So that's equal to negative 2 plus or minus the square root of 12. So negative 2 plus or minus, oh sorry, not the square root of 12 over 2, which is square root 3. So we have, that's the cotangent of x, so we have tan x is equal to 1 over minus 2 plus or minus root 3. Okay, so let's do two cases, 1 over negative 2 plus root 3 and 1 over negative 2 minus root 3. So for one of these cases, we have two values. If we plug this in, 1 over minus 2 plus root 3, and we go inverse tangent of that, we get the value, a negative value, so add pi, so we get 1.83. If we add pi again, then we get 5.76, and then for this one, we have 1 over negative 2 minus root 3. So if we add pi, we get 2.87. And if we add pi again, we get 6.02. So yeah, we should get 4 values for that. And yeah, that should be pretty much it. So I hope you enjoyed the speedrun. I hope you maybe learned something. And I hope to see you in the next speedrun.